students, you're welcome once again to another fascinating math video. In this video, we shall be considering a problem taken from trigonometry. And before I continue the solution of this problem on the board, I want to present before you the following services I offer. I offer an online math tutoring service for primary level students, secondary level students, and college level students. So if you're interested in these services, be very free to get across to me, right? So let us quickly look at the solution of this problem on the board. And also ensure to like the video, share the video, and subscribe for more. So now we are required to prove the trig identity, or to prove that 1 plus tangent of A minus secant of A over secant of A plus tangent of A minus 1 equal to 1 plus secant of A minus tangent of A over secant of A plus tangent of A plus 1. Now, how do we solve this monstrous problem? It is very easy just for you to know what to do at a time. Now, if you observe this expression on the left-hand side critically, you will discover that we can actually replace this numerator by a difference of two square expression. All right? Let us go about it now. For example, observe that. Consider the expression, for example. Look at the expression 1 plus tangent of A squared minus secant of A squared. Look at this expression, all right? Now, you agree with me that this is a difference of two squares. As a simplisher way of representing things, you look at this, A squared minus B squared can be written as A minus B multiplied by A plus B, all right? This is a difference of two squares with a monomial term. So if we apply this, the same method of factorizing to this expression, we shall have the following. We shall have this as equal to 1 plus tangent of A minus secant of A multiplying 1 plus tangent of A plus secant of A. All right? So we'll have this expression. That is, this expression here is equal to this. From this right-hand expression, we can make this expression the subject formula. Why this choice? If you observe once again, look at this expression on the numerator. 1 plus tangent of A minus secant of A is appearing here already. It's 1 plus tangent of A minus secant of A. Can you see that? Look at it at the numerator. So we can make this guy the subject of the formula so that we substitute our resulting expression. So if we do that, we shall divide both sides by this, you see here. So let's do that. We divide both sides by this. So if we divide both sides by this, we have the following. We have our result to be 1 plus tangent of A minus secant of A to be equal to 1 plus tangent of A all squared minus secant squared of A over, then divide by this, 1 plus tangent of A plus secant of A, because our aim is to make this expression the subject of the formula. So in doing so, we cannot replace this entire expression by this left-hand side expression, all right? So that means this original expression you see here, this left-hand side expression you are seeing here, this will becomes automatically, I don't want to write things many times. I want to avoid repetition. So in place of 1 plus tangent of A minus secant of A, I shall put this expression there. So we shall have 1 plus tangent of A all squared minus secant squared of A over 1 plus tangent of A plus secant of A, then all divided by this denominator, right? You see this one here. So after replacing this guy, we have this one there. But by normal algebraic process, this expression you see cannot be written as secant of A plus tangent of A minus 1 multiplied by 1 plus tan of A plus secant of A. Can you see that? All right. So this expression, 1 plus tangent of A squared, that is this entire expression you are seeing here, if this should be divided by this denominator, the resulting expression should be this. All right. Can you see that? So we are at a very good point. Now let us expand this numerator and see what obtains. Let's expand this numerator. So if we do that, we have this result to be equal to 1 plus 2 tangent of A plus tangent of A squared, or tan squared A, all right, minus sec squared A. But from trigonometry, sec squared A can be written as 1 plus tan squared of A. All right? So we have this in the numerator, all divided by this expression at the denominator. So we have sec A plus tan A minus 1 multiplied by 1 plus tan A plus sec A. Can you see that? So we're almost there at the solution. Now, if you observe this, if we distribute into this parentheses, this become negative. And from whence this negative one, we cancel out with this. Then also this multiply this, we have negative tan squared A. From whence it will cancel out with this. So we're left with the expression 2 tan A. All right. So this becomes 2 tangent of A over, we have sec A plus tan A minus 1 multiplied by 1 plus tan A plus sec A. Can you see that? Now, the only trouble with this expression is this expression at the denominator. Don't forget, we are required to prove that this left-hand side you are seeing here is equal to this right-hand side. Now, if you observe the right-hand side, at the denominator, we have sec A plus tan A plus 1. And that is exactly what you are seeing here. Now, the only addition to it is this expression. The question now is, how do we eliminate this expression? Now, we shall seek for a proper replacement. Now, we want to replace this 2 tan A by an expression that is identical to it. So let's think of multiplying this expression you are seeing here by this expression and see what it will give to us. So let me call this one equation star, for example. All right? Let me call this equation star. Can you see that? So I will think of multiplying this expression at the denominator by this expression at the right-hand side and see whether the result will give me 2 tan A. All right? So if it can give me that, I will replace 2 tan A by the product I've just chosen. So let's do that. So now let me call this star. I will say consider the products sec A plus tan A minus 1 multiplied by this expression, right? So we have 1 plus sec A minus tan A. Are you seeing that? So let me wipe this out of the board and so we can continue the work. Please don't forget, if you draw any value from this video, do me the favor to like the video, also share it so that I can get to a greater audience. Okay, so we have this at hand. Now we shall modify this expression to fit a very nice expression. That is a difference of 2 squared. Now how do we do that? We can write this expression we are seeing here, we can write it as equal to sec A, then this becomes minus, or we now have 1 minus tan of A, then close bracket. Do you agree with that? Let me use square parentheses to bring about the distinction. So we have this expression to be the same as this, because on expansion, we shall have this back again. Can you observe that? All right, I believe you observe that. Now, also, this one here can be written as bracket or sec A, then we have plus, let me put this, 1 minus tan of A. Are you seeing that? Now, this expression here is the same thing as this. All right? So, if you observe these two, it's as if, let us call sec A our A, for example, and call 1 minus tan A our B, for example. All right? So, we shall have this. If we replace sec A with A, by A rather, and we replace tangent of A by B, we shall have this expression. All right? Now, the same thing we go here. We have A plus B. All right? Now, this expression, this product is equal to writing the difference of 2 squares, such as A squared minus B squared. Can you see that? So if we follow this approach, we shall have this result as sec squared A minus 1 minus tan A all squared. Are you seeing that? That is the difference of 2 squared. Where sec A is my lowercase a and 1 minus tan B is my lowercase b. All right? So on expanding this expression, we have it as sec squared A minus 1 minus 2 tan A plus tan squared of A. Can you see that? Then don't forget sec squared A from basic identities. This can be written as 1 plus tan squared of A. Then expanding this minus, we have minus 1 plus 2 tan of A plus that is minus rather, minus tan squared A. All right. Now this will cancel out with this, and minus 1 will cancel out with this. So we have this as a result. That is to say that these two tangents of A can be replaced by this product, because we have just shown that the product gives us two tangents of A. So in the place of 2 tan of A, I'll write this expression there. All right, so you see we're not doing things blindly. We know what we're actually doing. I believe you are getting value from this video. If you do that, then do me the favor or to like the video and also share it so I can get to a greater audience. So let us do the replacement. Let's replace this 2 tan A by this product. All right, so therefore from star, we shall have, in place of this guy, I'll put this expression here. So we have sec A plus tangent of A minus 1 multiplied by 1 plus sec A minus tangent of A. So that this is standing in the position of 2 tan A, all divided by this denominator, which is sec A plus tangent of A minus 1 multiplied by 1 plus tan of A plus secant of A. Can you see that? Now you can see that this expression that was the barrier cannot cancel out with this because they are exactly the same, all right? So this will divide out with this, and we are left with the expression 1 plus sec A minus tangent of A over 1 plus tangent of A plus secant of A. And this is what we are required to prove, all right? So we've come to the end of this fascinating math video. Do me the favor to like and share it, and don't forget that I offer private services for students in the primary level, secondary level, and over for college level, often for schools. If you want me to be a tutor in your school online, I'm very available for that. So thank you very much till we meet again.